China and the AI race. Over the past 10 episodes, we built the friction matrix, a framework designed to measure how nations are adapting to the AI and automation revolution that is already underway. It looks at 10 structural signals we believe are strongly correlated with how quickly a country can absorb, deploy, and scale advanced technologies. So now we apply it to China. How does China rank? Where is it strong? Where is it constrained? Let's see what the friction matrix reveals about China's position in the AI race between nations. China's friction score, 0.31. This is China's full friction matrix profile. In simple terms, low friction means a country's structure is aligned for rapid AI and automation adoption. High friction means more resistance and slower adaptation. The scale runs from 0 to 1, and it's relative to the countries we're evaluating. Around 0.5 is the middle ground. Lower numbers suggest fewer structural barriers to scaling AI. China lands toward the lower end overall, but the details matter. Some of China's metrics are cutting edge, others are closer to average, and a few metrics indicate potential barriers to AI and automation. First, let's look at where China is pushing to lead the pack. Where friction is low. Privacy in the friction matrix measures whether a society leans toward data efficiency or strict privacy protection. We use financial and medical data accessibility as early indicators. In China's case, lower friction suggests a structural willingness to coordinate and utilize large data sets. Safety measures whether a society prioritizes precaution or deployment speed. Using biotech approval timelines and cost as a proxy, China's compressed regulatory pathways signal an institutional tilt toward efficiency and faster technological rollout. Digitization measures how willing a society is to convert physical systems into digital ones. Using smart meter penetration and digital identity adoption as leading indicators, China shows strong early participation in digital integration, signaling openness to deeper AI-driven transformation. Where friction is moderate. Government friction measures accumulated institutional mass. In simple terms, it shows how much of the economy runs on protected roles instead of open competition. It captures the share of the population with a vested interest in maintaining the existing rule structure. We use two proxies. First, the share of the workforce in credentialed or institutionally protected roles. Second, the share of GDP generated by sectors whose revenue depends on statutory allocation or government-defined contracts. Together, these indicate how much economic value is tied to preserving current institutional frameworks. In China's case, the share of the workforce in protected or state-affiliated roles is about average among the countries studied. However, those roles account for a comparatively smaller share of total economic output. In plain terms, institutional actors exist and may resist change, especially if AI begins replacing their jobs or weakening their authority, but they do not control most of the economy. That places China slightly on the more flexible side in this category, with potential backlash present, but less economically dominant than in more heavily institutionalized systems. Where friction is higher. The last friction category for China is ownership, which is really about economic stabilization. If AI replaces entire job sectors while total output rises, does the system have a willingness to redistribute income at scale so citizens remain economically secure? We measure this with two indicators. First, how many people actually receive job loss benefits across the population? Second, how much total cash is redistributed per person through those programs? In China, both numbers are relatively low compared to the other countries in our sample, which places China on the higher friction side of this category. Redistribution exists, but it plays a smaller role as a stabilization mechanism. Labor disruption is managed primarily by maintaining employment, not detaching income from labor. If AI begins eliminating sectors, large-scale automation becomes politically difficult without a broader redistribution system. China's friction position, final insights. Across most of the friction matrix, China is structurally positioned for speed. It is comfortable coordinating large systems, moving quickly on new technologies, and integrating digital infrastructure at scale. The country is oriented toward execution and rapid deployment. But automation is the pressure point. China's social stability model is built around keeping people employed through state-owned enterprises, industrial policy, and labor absorption. That makes sense in a world where expanding production still requires more human labor. AI changes that equation. Its advantage comes from eliminating labor demand while simultaneously increasing output. If automation spreads across whole sectors, China would have to redesign how income is distributed because an employment-based stability model cannot coexist indefinitely with labor-reducing automation. Join us for Part 12, where we find out how Russia scores in the friction matrix